Guys, are you able to hear now? Guys, are you able to hear now? Yeah, you got to be. अरे लिंक लिंक शेयर करना ना. बाहर रहने का देखना सर. टैग पता होना चाहिए ना, तो थोड़ी कुछ भी टैग कर देंगे. ये है. राइटिंग बहुत खराब रहेगी इसमें.
Okay, we'll start in 1 minute. We'll start in 1 minute.
बोलते रहो. Same link. Okay.
Guys, it's the same link that you have to use. So there is no change in the link. I was getting a lot of requests from a lot of people that before the your examination will have to finish the concept of human eyes and the related questions. So what I have done is that today's sessions primarily I'll focus on human eye, because this is one thing where I have got a lot of requests from a lot of people. So entering the session, uh, before I start human eye, we have all discussed the concept of lenses, that how convex and concave lens, depending on the value of u, it means that where I place the object, and depending on the focus length of that particular lens, where the image is formed. So the formula in that case was, if I write the formula, it was 1 by v minus 1 by u is equal to 1 by f. The same concept would be utilized in case of human eye also. Now, before I start explaining with the help of formula, let me discuss a few things uh, which are important in case of human eye. So first of all, if you look at here, so how the image is formed inside the human eye. So it acts like a camera. What do I mean by this statement? So I have drawn a figure, or I have a ready-made figure for you, which has been shared on the screen. You look at the figure on that screen. I'll start explaining each part of human eye, which will help you understand the concept of formation of image inside the human eye. So what happens? The light falls mainly on cornea. So see, where is cornea? Cornea is here. This is your cornea, and mostly the light falls over here, and absorption of light, entering of light into inside the eyes occur at this particular point, which is called cornea. Now what happens after light enters it? So there are two three important parts of the eyes, which are pupil, iris, and ciliary body. So look at here, this particular portion, this particular portion is basically your lens. This particular portion is your lens. So what happens? You have iris over here, which controls what amount of, look at here, this is the iris. I'm drawing a line over here. This is the iris. Now what does iris do? Iris regulates the side of pupil. Where is pupil? Pupil is here. Keep on looking at the screen where I'm making the diagram. Iris controls the size of the pupil. What is the role of pupil? Pupil decides what amount of light it has to take. The intake of amount of light is decided by pupil. Now try to understand, where is the image formation happens. Image formation always happens at retina. What does this statement tells me? See, this particular, or if I look at the complete eye, the diameter of the eye is nearly 2.3 centimeters, which is not going to change. I mean, I'm talking about a normal eye which is working properly. This would be 2.3 centimeters. And this distance is generally fixed. What do I mean by this distance is generally fixed? So if I write a formula for you, if I write a formula for you here, 1 by v minus 1 by u is equal to 1 by f. Now, if this distance is fixed, this is lens and image is getting formed at retina here. What happens is that this amount of, or magnitude of v is always fixed. If magnitude of v is always fixed, and the magnitude of u is always changing depending on where the object is, we have to properly change the f so that the v remains constant always. Now how do we change the focal length, or how does I understand that I have to change the focal length? So you have ciliary body. This ciliary body is responsible for change in the focal length of the eyes. And how does it change in the focal length? So understand a condition when a lot of, or you have to see something at very far from your eyes, suppose 100 meter, 200 meter. So generally your eyes are wide open, but when something is very nearby, suppose say 30 centimeters or 40 centimeters, then your eye starts contracting. If it start contracting, if it starts becoming something of very less diameter, that's how this ciliary body is able to, this ciliary body which is here is able to change the focal length. So depending on the position of the object, ciliary body changes the focal length of the eye so that the V always remains same and the image is always formed at the retina. Now try to understand after this what happens. So once the ciliary body has adjusted the focal length f, after that what happens is the image is formed at retina. What kind of image is formed at retina? Always remember what kind of image is formed at retina. Always remember the eye inside it on retina forms a real and inverted image. Please write it down somewhere. This is very important and it is asked time and again. The on the retina the image formed is always real and inverted. Now the question is, if inside the retina the image formation is always real and inverted, how do we how do we perceive or how do we see any object as erect if it is erect? Suppose any object is erect like this. Look at here. There is a erect like this, and the retina forms real and inverted image like this. How do we perceive it like this in actual world? What happens? So to understand this, we have to understand that this retina is from this portion, a lot of optical nerves are there which goes directly to the brain of the human body. You look at here, this particular portion is optical nerve which is in contact with the retina, and it goes where? It goes directly to the brain. Now what happens here? Retina has a lot of optical cells. What do you mean by optical cells? They are light sensitive cells which gets activated when it is illuminated by light. A lot of optical cells are there, optically active cells are there, and whenever a light falls on it, they get activated. Now in retina only there are different cells which convert this optical image into electrical signals. Where optical images are converted into electrical signals? Optical images are converted into electrical signals inside the human eye at retina, and these electrical signals are sent to the human brain. Now try to understand and write this thing which is not given anywhere. Inside the human brain there is something called corpus corpus callosum, callosum, corpus callosum. What is this corpus callosum? So you understand, any normal human being will have two eyes. Now image formation of any particular object will happen at both the eyes. Now after the image is formed in both the eyes, both the images are congregated together at corpus callosum, and at corpus callosum, after the congregation, it is sent to the other cells of human brain where this real and inverted image is changed to the erect image. So that's how, because the image which is getting formed inside the human eye is real and inverted, inside the brain it is converted into real and erect, and that's why we are able to see any particular object in the form it looks us, I mean in the form we are able to perceive it. And looking at that, or due to that particular mechanism, the whole world that we see looks as per it is. Now there are few other things that we need to understand. So people ask that, or there are so many questions that what is the role of aqueous humor? First of all, where is aqueous humor? There is a liquid over here, and this is called aqueous humor. So people ask that why eye is bulged in the front. Eyes are bulged in the front because of presence of this aqueous humor. What is the second role of aqueous humor? Aqueous humor also acts as primary lens for few certain focal length, we can say. So aqueous humor has two objectives, primarily two objectives, let me say. First, it provides bulging, and second, it acts as a primary lens for the incoming rays. The second one is this particular portion is vitreous humor. What is the role of vitreous humor? So role of vitreous humor is that this prevents eyeball from collapsing. If this liquid is not there, these eyeball can collapse among each other. And what will happen is that the eyeball will shrink. And when eyeball will shrink, the image formation will not be proper, and there would be a problem in sighting different objects. The other important parts of uh, human eye, which is this particular portion. If you look at the outer side of it, this is here, this particular outer surface. This outer surface is called sclerotic. Sclerotic is nothing but it provides shape to the eye, different shape to the eye. What is the what are the different objectives of it? First one is to providing shape to the eyes. It also protects the eyes from the outside atmosphere. So so this sclerotic has two different objectives. First one is giving shape to the eyes, and second one is protecting it. Other important parts are, which are very important, is inside the retina. So write this down. This is hardly present in any book. Inside the retina, we have two kinds of cells. First one is rod cell, and second one is cone cells. Rod cells, let me just remove it. I don't need it now. Let me just remove it. I don't need it now. So inside the retina, I have two kind of cells. First one is rod cell, and second one is cones cones cell. Now, what are they for? So you try to understand, this cone cell is for identifying color, and this rod cell is for identifying brightness. Now try to understand what are the importance of rod cell and cone cell. See, when the light rays come inside the human eye through cornea, what happens is that cornea simply sends the light cell. It does not identifies the color and the brightness. Now, where the color and the brightness of the object is decided. So color and the brightness of the object is decided on the retina, on the formation of image. Which cells are responsible for brightness? Rod cell is responsible for brightness. Which which cell is responsible for color? Cone cells, CONES. I have not written the spelling right. CON. Look at here. CONES. Cone cell. This cell is responsible for color. Now, cone cells are of different type. Primary cone cells, secondary cone cells. primary cone cells will identify red, yellow, green kind of color. And if there is any problem in cone cells, if cone cells are not proper, if cone cells are absent, then the person will not be able to recognize that what color is coming inside the eye, and hence the problem of color blindness. So if somebody asks you that which particular cell, absence of which particular cell is responsible for color blindness, cone cells, absence of cone cells is responsible for color blindness in human body. If cone cells are absent, they are not functioning properly, human body will not be able to differentiate between different colors. And if it is not being able to differentiate between different colors, hence that person would be color blind. So this was the this was the explanation of different part of human eye. If there is any doubt, you can post it in the chat box. I'll wait for 20 seconds, you can say, so that I can explain if there is any doubt. Otherwise I'll move ahead and I will explain formation of image inside the eye. I will also explain different type of defects and its rectification, and I will also solve 3 4 questions, so that uh, because a lot of people have been sending me different questions based on human eye, that we have not done this kind of question. So I have selected 3 4 questions, and based on that I will be solving questions. Is there any doubt, guys? You can post in the chat box. I will upload. I will upload it again. I will upload the human eye. I will upload the human eye picture again, and I'll explain if needed. So kindly post it if it is required. Otherwise, I'll start with formation of image. Okay, nobody is posting anything, so I'm moving ahead. I'm moving ahead with the formation of image. Okay, so how image formation happens inside the, what is that mechanism of formation of image inside the human eye? So please understand, as I have already explained. Suppose, let me just draw a diagram for you. Suppose suppose this is the human eye and this is the lens, and suppose any object is here. I am drawing a line which goes to the retina, suppose here. And suppose an object is like this, which is erect and at certain distance d. Now what happens, v is already decided, which is from this lens to retina. Now what happens? I have ciliary muscle which will decide that what kind of focal length is needed to form the particular image at the retina, and what kind of image would be formed. So you see here, a light rays goes from here, and from here it happens like this. It goes like this, so that a real, something like this, a real and inverted image is formed of same length at this particular point. I'm marking it. This is our retina. Now try to understand what happens if there is some kind of deficiency inside the eye. What do I mean by deficiency? So let me come to defects of vision and its rectification. Before that, let me explain you the concept of least distant distance of distinct vision. What do I mean by least distance of distinct vision? So least distance of distinct vision is nothing but it is the minimum distance at which objects can be seen more distinctly without strain. What do I mean by this? So try to understand generally for a normal eye, for any distance less than 25 centimeter, if the distance is less than 25 centimeter, we have to strain our eyes, we have to contract our eyes in such a fashion to look at the particular object very carefully. Other, if you don't strain it with normal eyes without any strain, it will be difficult to look at that particular object. So least distance of distinct vision is least distance of distinct vision for normal eye, for normal eye is equal to 25 centimeter. What do I mean by it? Anything which is less than 25 centimeter, identification of that object, looking at that object without straining of eye would not be possible. I mean, the proper image of that object on the retina would not be possible to be made without straining your eyes. And that is what is called least distance of distinct vision. Now, how does this data of 25 centimeter is important? This data of 25 centimeter is important. Guys, I have been getting a lot of doubt. Like Ronak has posted how is night blindness clock caused. I'll take these doubts at the end of the session. So give me some 10 minutes of time. I'll explain these things which I'm explaining now, and then I will take your queries. So please give me 10 minutes of time. So this is 25 centimeter. Now, how this data is important? This data is important in the sense that whenever there is a deficiency, like there are two kind of deficiencies which is important. I mean, there are others also which I discuss, but first one is myopia and second one is hypermetropia. In case of hypermetropia, what is hypermetropia? Let me start with hypermetropia. So hypermetropia is something where a person is able to comfortably see something at a distance, but when something is nearby he is not able to see. Why does that happen? I'm again explaining. Hypermetropia or long sightedness is a kind of eye disease. And what happens in that? In that, a person is able to look at something which is at what happens in hypermetropia or long sightedness is that person is able to look something which is at distance, but something which is at nearby he is unable to clearly view that particular thing. So in a person who is unable to locate something which is nearby is suffering from hypermetropia or long sightedness. Why does that happen? What is the meaning of this particular line? Try to understand this least distant of distinct vision, which is for normal eye 25 centimeter. In case of hypermetropia or long sightedness, it increases from 25 centimeter and go beyond 25 centimeter. It can become 40 centimeter, 50 centimeter, or 100 centimeter, depending on uh, how much is the extent of disease. So if somebody is saying, or if you come to know that a person is suffering from hypermetropia, from now onwards you should understand that least distance of distinct vision, which is 25 centimeter for a normal eye, for that particular person it would increase from 25 centimeter and go beyond 25 centimeter. So that is the meaning of hypermetropia. Now try to understand, guys, what do I mean by hypermetropia. I have already explained to you how to overcome this particular defect. Now what happens is that when a person is not able to see something at very ne- near, when a person is not able to see something which is very nearby, his vision needs to be corrected. Now what is the optical object by which his vision is corrected? So try to understand in this case what happens, what is the mechanism in which the image is formed. Try to understand, generally for a normal eye the image is formed on retina. Now in hypermetropia, uh, what happens is that distance between the lens and the retina is decreased. So if I draw a particular eye for you, so suppose this is my lens and this is my retina, this complete thing is my retina. Suppose this for normal eye, suppose this is V. For anything with long sightedness, this V reduces, V goes down. Now what happens when V goes down? The image would be formed beyond the retina. The image would be formed after the retina. So how this can be corrected? Now to correct it, I need to reduce this particular. Now this is the actual V. This is the actual V which is in case of long sightedness. Suppose this is V1. So V1 is greater than V. Now what happens is that if I correct the eyesight, if I have to correct the long sightedness, this V1 has to be reduced to V. If I am able to reduce V1 to V, in that particular case long sightedness can be reduced. Now how can you do that? So to do that, we use convex lens of suitable focal length. So what kind of lens is used? We use convex lens. Write down this is asked in one markers. So convex lens is used in case of long sightedness or hypermetropia. How does convex lens help in overcoming long sightedness? So I'm writing this, try to understand. 1 by V is equal to 1 by, or let me just remove it, let me just rewrite it. Try, please wait for a minute. Understand it. The formula is 1 by V minus 1 by U is equal to 1 by F. Now for a convex lens this U would be negative, so let me use the sign convention. This becomes 1 by V plus 1 by U is equal to 1 by F. Now what happens is that 1 by V is equal to 1 by F minus 1 by U. Now what has happened? I have to reduce this V. As I have already written, the V has to be reduced. When the V goes down, 1 by V goes up. In that, as this focal length is always same, because what happens, I cannot change the focal length because it is an object inside the human eye which is fixing this focal length. As fixing of focal length happens with ciliary muscle, what happens is that this F is not going to change, so you have to change U. How will you change U? What do I mean by changing U? Changing of U means that wherever the object is now, I have to realign it at certain position so that the V becomes, or the V is such that the image is formed at retina. So try to understand when V is getting reduced, as I have already discussed, 1 by V goes up. If this left hand side is going up, you have to increase the right hand side also. How will you increase right hand side? When 1 by U goes down. If 1 by U goes down, U has to increase. What do you mean by U has to increase? So try to understand how it happens. It happens like this. In front of the human eye, just let me make it. In front of the human eye, we keep the convex lens, something like this. So suppose, um, let me just remove it once again. Suppose this is the human eye, and what we do is that we keep a convex lens here, and what happens is that if an object is here, suppose if an object is here, I have to increase the U, as you have already seen in the, as you have already seen in the last uh, discussion. So what happens is that from here the light rays will come and go and strike the convex lens, and after striking the convex lens, the refracted rays would go beyond this point, so that the U, which is currently this, increases up to this particular point. So that is how convex lens helps in increasing the, that is how the convex lens help in increasing the U in this particular condition. I am again saying 1 by V is equal to 1 by F plus 1 by U. Now what happens is that this V has to be reduced. Why V has to be reduced? Because the image is getting formed after retina. It has to be formed at the retina. It means that distance between the lens and retina which has changed. Now I have to change my V according to that. Hence V has to be reduced. If V has to be reduced, 1 by V will go up. And if 1 by V has to go up, then in that particular scenario, I'm sorry, this is a negative sign. So 1 by V has to go up. For 1 by V has to go up, 1 by U has to be reduced. And in that scenario, U has to be increased. To increase U, we need this convex lens, and when we need this convex lens, the light rays strikes this convex lens and goes far away from the convex lens, and hence the U increases. So this is how, this is the exact mechanism why somebody with long sightedness or hypermetropia, he is given a convex lens to wear in front of his eyes, so that whatever object is in front of the eye, with the help of the convex lens, the distance of the object from the actual eye can be increased, so that the image formation can happen at the retina. So this is the formation. If there is any doubt about this, you can ask me, otherwise I'll move to myopia. So I'm moving to myopia now, and then I'll have to solve a few questions. So guys, try to understand what is myopia. Now, in case of myopia, what happens? It is exactly opposite to long sightedness. Myopia is also called short sightedness. What do I mean by short sightedness? There are two things. There is it is exactly opposite to long sightedness. So what happens here? A person is able to see something. A person is able to see something which is nearby, but a person is able to see something which is very far away. So in that particular case, what happens? How this mechanism works inside the eye? So the mechanism of this is, the mechanism of this is because in this particular defect there is a slight elongation of the eyeball. So what happens? There is a extra bulging of the eyeball, and the distance between the lens and the retina is increased. As the distance between the lens and the retina is increased, lens of the human eye and the retina is increased, the image formation does not happen on the retina. The image formation happens in front of the retina. Now what happens over here? Here, suppose this is the human eye and this is my lens and this is the retina. Now as this particular distance has increased, the image formation happens here, and this particular disease or this particular defect is known as myopia. Now what happens in this particular case, or what can be done to overcome it? To overcome it, the image formation which is happening here has to be taken at retina. It means what? It means that in the eye of the person, this is the v, actual v. Now for clear image formation, the v has to be shifted here. So suppose this is v1. So now my v1 has to be greater than v. How can I do so? I see, again the focal length would be same. Let me write the formula for you. 1 by v minus 1 by u is equal to 1 by f. Now 1 by v is equal to, as because there would be this would be negative if I take sign convention. So this becomes positive on this side. When it goes on the other side, it becomes 1 by f minus 1 by u. So 1 by v is equal to 1 by f minus 1 by u. Now what happens? What I have to do? My primary objective in short sightedness is to increase this v. If v increases, if v increases, then 1 by v will be going down. If 1 by v will go down, then what I have to do? What I have to do? This also has to reduce. To reduce this, as 1 by f is fixed, I have to increase the value of 1 by u. So what I have to do? 1 by u has to increase, or u has to decrease. If u decreases, so it means that in myopia, what happens? I have to use such kind of lens which, with the help of it, or by using the lens, the distance between the human eye and the object with the help of the lens should reduce. Which lens can help me do so? So in this particular case, concave lens is used. We use concave lens. What happens in case of concave lens? So try to understand. If I make a concave lens here, or suppose if I make a concave lens here, and suppose a light ray is coming from far off object. I'm making the light ray from far off object because in myopia the person is not able to see something which is coming off far off position, or a person or an object kept at a far off position, the person is not able to see it. So what happens here? The u is very high. I need to reduce this value of u. So that is why I have kept this concave lens. Because what happens after refraction? Where does it go? So after refraction, the new image of the object will be at this particular position. So for a normal eye, the u was from here to here, from here to here. Now it has changed to this new value which is lesser than the previous value. So which lens helps us do so? In myopia we use concave lens. With the help of concave lens we decrease the distance between the human eye on the and the object. By decreasing the distance between human eye and object, we finally change the value of V. The value of V between the lens and the retina, we are able to increase it so that the image can be formed at the retina. So these are the two things which are very important in case of defects of human vision and is time and again asked. The next thing is a few problems. So I can state those problems, or if you have NCRT books with you, you can refer to NCRT books. I am referring to those NCRT those questions in the NCRT books. People have definitely asked me 2 3 times these questions. First question is, a person needs a lens of -5 point. It has been given, power has been given like this. But here, power has been given like this. Power is equal to minus 5.5 diopter for correcting the distance, his distance vision. He is correcting what vision? Distance vision. Now, distant vision means what? Myopia. So, correction of myopia, negative power is being used. And the question is, what should be the focal length of the lens? So what I have to find here? I have to find focal length. What is focal length? Distance relationship between power and focal length. Power is equal to 1 by focal length, and this focal length has to be in meters. So if I want to find out focal length would be equal to 1 by P, and P would be in diopters. As it has already been given in the diopters, I am writing it here. It is 1 divided by minus 5.5, which is equal to minus 2 divided by 11. How much it would be? It would be equal to minus 0.18 and nearly 2 meters. Or you can convert it into centimeter by writing 18.2 centimeters. So if somebody says you that to overcome the distance vision problem, if power is given minus 5.5 diopter, what kind of focal length is needed? So focal length needed would be 1 divided by minus 5.5, or which is minus 2 by 11, that is equal to 18.2 centimeters. The second question here only, this is question number 5 of chapter 11 of NCERT. The second question, the power has been given as 1.5 diopter. So focal length would be equal to 1 divided by power, and that is equal to 1 divided by 1.5, which is nothing but 2 by 3, and that is equal to that is equal to 0.66 meters or 66 centimeters. So this is how you can solve question number 5. Now there are two more questions which are important here. The sixth question is, okay, the sixth question is, The sixth question is, let me read it. The far point of a myopic person is 80 centimeter in front of the eyes. The far point is, for a myopic person, is 80 centimeter in front of the eye. What is the nature and power of lens required to correct the problem? What do we do in case of myopic person? What is the far point? First of all, try to understand. I have discussed about I have discussed about distance, least distance. What was the least distance? Least distance was 25 centimeter in case of a normal eye. What did I mean by least distance? Least distance was that if any person wants to listen to if any person wants to see something of less than 25 centimeter, he needs to contract his eyes without strain. Looking at that particular object would not be possible. Okay, so let me solve. What do you mean by far point? Far point means he can look up to that point only. What do you mean by myopia? Myopia tells that a person is able to see near object, he is not able to see far object. So far point means he is able to see up to 80 centimeter only. He'll not able to see something which is far from 80 centimeter. So whatever is far from 80 centimeter, I have to readjust the image of that particular object with the help of the lens at 80 centimeters. It means that you look at here, I will write down the formula. 1 by V minus 1 by U is equal to 1 by F. Now what happens? U has to be 80 centimeter for the human eye. If U is 80 centimeter, because the person's far point is 80 centimeter, he is unable to see anything beyond 80 centimeter. Sorry, this V has to be 80 centimeter for anything. So for human, 1 second, let me explain it to you. This is my human eye, and I'm keeping a concave lens here. And what happens, this is something which has been kept beyond 80 centimeters. This is more than 80 centimeters. Now what happens if something is beyond 80 centimeter? The eye will not be able to see it properly. In that particular case, what needs to happen is this concave lens comes into picture. What does this concave lens do? So this concave lens, whatever object is kept beyond 80 centimeter, this concave lens will try to form image of that particular object. Suppose the object is O. So this concave lens will try to form image of O at a distance of 80 centimeter from the eye, so that I can make the image of this reformed image at the retina here. So what happens for this concave lens? This V would be 80 centimeters. U I will take here as infinite, because something coming from far, I will be taking the U as infinite. So I am keeping the value 1 divided by V is minus 80, because it is getting formed opposite to the direction of the ray, divided by 1 by infinite is equal to 1 by F. Now what happens? F comes out to be, from here, F comes out to be minus 80 centimeters, or minus zero point 0.8 minus zero point 0.8 meters. Now what is power? Power is equal to 1 by F, which will be equal to 1 divided by minus zero point 0.8, which is nothing but, what is 0.8? 0.8 is 4 by 5. So I am writing 5 in the numerator and 4 in the denominator, that is equal to minus 1.25. So diopters. So this is the answer of the question. The question was that for any particular person, I'll again read the question and revise it for you. The far point of a myopic person was 80 centimeter in front of the eyes. What is the nature and the power of lens required to correct the problem? First of all, as soon as I come to know that the person is myopic, and the second hint that has been given in the question is far point, I know that the person has short sightedness. It means that he is able to see something nearby, but he is not able to see something at far off distance. As soon as I come to know this particular fact, I should know that a concave lens has to be used. The data given about far point is 80 centimeter. It means that something beyond 80 centimeter, person will not be able to see it properly. Now, if a concave lens is used in this particular condition, the concave lens should be able to form the image of something very far off at 80 centimeter from the eye, so that the eye can locate it properly, or within 80 centimeters, so that the eye can locate it properly and form the image at retina. For that, I have used the formula 1 by v is equal 1 by v minus 1 by u is equal to 1 by f. U I am assuming to be infinite because I am talking about far off distance, and the final location of the image has to be 80 centimeter from the eye. It means that the concave lens image formation has to be at 80 centimeters. That is why I am keeping v value as 80. As soon as I find v value at 80, what I'll do is that I'll find out the value of f, which comes out to be minus 80 centimeters, and then I'll convert it into power. So that is how you have to solve this question. Okay, next question. Next question is, the near point of a man with hypermetropic eye is 1 meter. What is the power of the lens required to correct this defect? Assume that the near point of the normal eye is 25 centimeter. As soon as I see that the person is suffering from hypermetropic eye, or person has hypermetropic eyes, or let me say long sightedness, and that is near point is 1 meter. Generally what happens, see here, the near point has elongated. It is generally 25 centimeter. Now the near point is 1 meter. It means that a normal person can see up to 25 centimeter clearly. Now the person who is having long sightedness cannot see up to 100 centimeters. Hence, when I use a convex lens in this particular case, the convex lens should be able to increase the value of u from 25 centimeter to 100 centimeter. What do I mean by this statement? What I mean is that as the person is not able to see something in the range of 100 centimeters or 1 meter, the image formation with the lens should happen such that the V in case of image formation is 100 centimeters. And that is how the person, now suppose this is I, and any person can see up to 25 centimeter. Below it, you have to strain your eyes. Now, this has increased up to 100 centimeter for a person with long sightedness. So what is the use of convex lens? So see what happens. The use of convex lens is, suppose I use a convex lens here, and an object is kept at 50 meters suppose here, or 50 centimeters suppose here. After image formation, the after image formation from this convex lens, the new u from this human eye should be 100 centimeter. If it is not 100 centimeter, the image formation from the human eye would not happen on retina. How do I write it in terms of formula? So 1 by v minus 1 by u is equal to 1 by f. Now how do I write it? So try to understand. V is how much? Suppose a particular object is kept at 25 centimeter because that is the least distance. So I am keeping V as minus 100 centimeter. U is minus, so I'm putting it with sign convention. This is 25 and that is equal to 1 by F. Now let me solve it. The LCM would be how much? LCM would be 100. So this comes out to be 1 and this comes out to be plus 4 and this is minus 1, I'm sorry, and that is equal to 1 by F. So 1 by F is equal to plus 3 divided by 100, or if I write F here, F is equal to 100 divided by 3 centimeters. Why centimeters? Because I have been keeping all the data in the centimeters. If I convert it into meter, F comes out to be 1 by 3 because I'll have to divide centimeter by 100. So this comes out to be 1 by 3 meters. Now what will be power? So power would be equal to 1 by F, which is equal to 1 divided by 1 divided by 3, that is equal to 3 diopters. So in this case a convex lens would be needed, which power would be 3 diopters. So these are the 2 3 questions which I wish to solve. I wish to solve. There are few people who have sent me. Okay, I'm getting the message that they've got. Now in your book, which you use in the NPS, there are few questions. Okay, people are asking that how can you take 25 centimeters? See what happens in the question. If you read the question carefully, let me read the question once again for you. Assume that the near point of the normal eye is 25 centimeter. So the question says that the near point of hypermetropic eye is 1 meter. How much it should be? It should be 25 centimeter. How much it is now? It is 100 centimeter. So my objective is to bring it from 100 centimeter to 25 centimeter. How can I do so? I can do so that whatever is at 25 centimeter, I can change the image formed by convex lens such that it goes at the 100 centimeter, and that is why I have taken U as 25 centimeter, because for normal eye the U is normally 25 centimeter. If I have a normal eye and my eyes are not defective, so anything kept at 25 centimeter, which is my near point, I will be able to perfectly see it. I have not been able I am not being able to see it up till 100 centimeter. That has to be changed to 25 centimeter. That is why I am keeping U as 25 centimeter, because whatever is at 25 centimeter, if I change that particular point from 25 centimeter to 100 centimeter, my uh, eye which has a problem of long sightedness would be able to see it very properly. Hence U has been taken as 25 centimeter and V has been taken as 100 centimeter. Any other doubt? The objective is that for normal eye, if it is 25 centimeter, and for defected eye it is 100 centimeter, whatever is kept at 25 centimeter, that has to go at 100 centimeter now. If it goes at 100 centimeter, my eye would be able to see it clearly, and it would be able to form the particular image at the retina. That is why I am taking U as 25 centimeter and V as 100 centimeter. Any other doubt anyone has? Any? You can post it in the chat box. You can post it in the chat box. Okay, somebody is saying me that he has posted. 1 second. Okay, Ronak, is it clear the questions that you have posted on my WhatsApp number? I will take one question for you, Ronak. That is question number 4. That you are saying me the far point of a myopic person is 150 centimeter in front of the eyes. Calculate the focal length and the power. This kind of question I have already done, which is the previous question. Here for a myopic person, 150 centimeter is there. So what do you mean by myopic person? Person is able to see nearby, but person is not able to see far off distance. So what has to be done in that particular case? In that particular case, what will happen is v would be equal to 150 centimeter, u would be infinity, and find out the value of f. The first question I solved like this, that was the question like this. Somebody is saying question number 3, a person can see clearly up to 3 meters. Prescribe a lens for a spectacle so that he can see clearly up to 12 meters. What is happening here? The person can see up to only 3 meters only. What kind of deformity it is? This is the problem of long sightedness, that the person is, sorry, this is the problem of I'm sorry, this is the problem of short sightedness. If this is the problem of short sightedness, and if the person is able to see only up to 3 meters, if the person wants to see up to 12 meters, whatever is kept at the 12-meter image has to be formed at 3 meter by the concave lens which I have been using. So here u would be used as minus 12 meters, v would be used as minus 3 meters, and you will have to find out value of f. That will give you your answer. So I am just giving you a hint how to solve this question. Question number 3 in the NPS book. Here v would be equal to minus 3 meters. Question number 3 in the NPS book, u would be equal to minus 12 meters. Use the formula 1 by v minus 1 by u is equal to 1 by f. Find out the value of f. You will get the value. So let me do it for you. That would be minus 1 by 3 plus 1 by 12 is equal to 1 by f, and likewise. So you can solve that question like that. Find out the value of f. I have already written the equations. Any other doubt that you have, you can post it. Okay, guys, so this is it from me today. Perhaps there was some technical glitches and there was problem in the handwriting also. So if you guys want this session to be repeated, I'll repeat this session once again. I'll repeat this session once again. If not, then okay, I have got it out. Okay, no issues. So I'm wrapping up the session today now because it's already 9 o'clock and few people requested me to wrap it up by 9 o'clock. If you want, you can leave a message to us that the session needs to be repeated. There was a technical glitch in the beginning of it, and after that also my handwriting was not good, as few of you complained. So I'm sorry for that. I will take care of it next time. I hope you understood all these things. Time and again, I was repeating a few things. I was making it verbose because I realized that this topic is difficult and I need to explain time and again so that you remember it. At least 8 to 9 people told me in last 2 to 3 days that to cover up this topic because they did not understand it properly. Even if you have doubt now, I can take this session once again for you if you want. Do let us know on the WhatsApp group. If you have any doubt, I'm saying it once again, you can post it now. Okay, no doubt, no one is posting it. So guys, thank you so much, and all the best to all of you. Thank you so much.